When we simplify radicals, another thing we have to look for is our denominator, and it cannot have a radical in it. This is going to be very similar to what we did when we looked at complex numbers, in the aspect that we couldn't have an I in the denominator either. When we worked with complex numbers, we said that we could either have a monomial denominator, in which case we would multiply top and bottom by I to get rid of that I, or a binomial denominator, in which case we multiply top and bottom by the conjugate to get rid of I. It's going to work exactly the same way with radicals. So if you notice here on this notes template, notice that with a monomial denominator, so we have only one term, we'll first reduce if possible, and then if we still have a radical after reducing, we're going to multiply top and bottom both by the same radical, or the radical part that's in the bottom. And if you look here, I have radical 4a times radical 4a. If I look at what happens when I multiply those together, I will get radical 16a squared, which just reduces to radical 16 is 4 and radical a squared is just a. So notice that multiplying by the radical part does indeed get rid of that radical. So it leaves exactly what I already had minus the radical. However, if my index is not a 2, so I'm not a square root, I have to multiply the radical that many times in order for the index to cancel. So notice right here I have cube root of 4a times cube root of 4a. Notice if I only multiplied the two of them, I would have the cube root of 16a squared, which would not get rid of the radical. However, if I multiplied three of them, I'd have the cube root of 4 times 4 times 4, so let's call it 4 cubed. A times a times a, let's call it a cubed, which then, if I split that in two, my cube root and my 4 cubed would reduce to 4. My cube root and my a cubed would reduce to a. So again, if I have that 3 times for my index 3, it would cancel out. Same thing if my index was 4, I would need 4 of them, index of 5, 5 of them, so on and so on. Now on the other side here, if I have a binomial denominator, so again, that's going to be two terms. They'll be separated by either add or subtract symbol, and I will multiply top and bottom by the conjugate. Again, just to show you why, if I have 2 plus the square root of 3x times 2 minus the square root of 3x, I know these are conjugates because they differ only by a middle sign. When I multiply these, again, I can use FOIL, or I can use my formula that says a plus b times a minus b is just a squared minus b squared. It is slightly faster than foiling. Using that formula here, I would get a squared minus b squared, which would give me 4 minus my radical and square cancel, 3x. So again, it does indeed get rid of that radical in the bottom. So I have 3 examples here. I have 2 monomial examples and 1 binomial example. So let's go ahead and take a look at these. So on the first one, I notice that the first thing I'm going to do is be able to reduce, because I can reduce these non-radical parts, 2 and 4, as well as these radical parts. After reducing, my 2 becomes 1, my 4 becomes 2, my 3 becomes 1, my x becomes 1, my 6 becomes 2, and my x cubed becomes x squared. I'm left with 1 times the square root of 1, which is just 1 on top, over 2 times radical 2x squared. So now I want to go ahead and get rid of that radical on the bottom, so I'm going to multiply top and bottom, since it is a monomial, by just the radical part. Doing that gives me radical 2x squared on top. This 2 on the bottom stays there. And radical 2x squared times radical 2x squared, you'll start to notice that the radicals just go away, and you probably will skip this step, but as long as this is the first time we've seen this, I'll put this step in. It's going to give me radical 4x to the 4th, which I just pointed out a moment ago is going to go back to what it originally was. So taking that next step, I'm going to have radical 2x squared over 2 times 2x squared. I always still have to reduce if possible. I notice that up on top, I cannot reduce radical 2 at all. However, if I have the square root of x squared, I can take one group of 2 out. So I get x radical 2 all over 4x squared. So last thing I notice that I can simplify by taking an x out of both top and bottom. I cannot reduce these since one is under a radical and the other one is not. And since 2 doesn't have any perfect squares, I'm going to have a final answer of radical 2 over 4x. And I am in simplest form since I cannot simplify my radical on top and I no longer have a radical in the denominator. I'm going to go ahead and look at example 2 next. I'm going to go through the same process. Even though it's a cube root, I'm still going to first reduce. So I'm going to reduce top and bottom by 2, leaving me with 1 and 2. An x squared and x to the 4th by x squared, leaving me with an x squared on the bottom and a 1 on top. So I have cube root of 2 all over cube root of x squared. So as we just looked at up above, the only way I'm going to be able to get rid of that cube root of x squared is if I multiply it by 2 additional cube roots of x squared, because I will need 3 in total. So I'm going to do that next. That will then get rid of that radical in the denominator. If I multiply bottom by 2 additional cube root of x squareds, I'm going to have to also do that to the top, giving me the cube root of 2 x squared times x squared is x to the 4th on top, all over. When I multiply the 3 of these, I get the cube root of x to the 6th, which then I can reduce the top because I see even though there's not a perfect cube in 2, I can take one group of 3 out of x to the 4th and leave 1 left on top. And I can take 2 groups out. Again, notice that as you get more accustomed to this, you can kind of skip this middle step and just recognize that I end up basically just dropping my radical after I rationalize that denominator. And then finally, I always have to check with the fraction to see if I can reduce. I can take an x out of both top and bottom, giving me a final answer of x times the cube root of 2x. Oh, excuse me, I took that x out of the top. So just the cube root of 2x all over x. And again, I'm in simplified form because I no longer have a radical in the bottom, and I cannot simplify my radical on top any further. Looking at one more example, the previous two I had monomial denominators. Notice in this example I have a binomial denominator. I cannot reduce with add or subtract, so please do not try to reduce these x's. The only reason I can reduce is if I have multiply, if I've taken a GCF out, so I cannot do anything with those. So right away I'm going to go ahead and multiply by the conjugate of radical 2x minus 5. So multiplying top and bottom by radical 2x plus 5. Remember, conjugates only differ in their middle sign. I always do the same thing to top as I do to bottom, and I only need the 2x under a radical. So on the bottom, I could FOIL, but I think it is faster to use my a squared minus b squared, a plus b times a minus b formula. On top, I'm going to have to FOIL. So I do first times first, outside times outside, inside times inside. Since they have the same index, I can go ahead and multiply and put them under one radical, giving me radical 6x to the 4th. Remember, when you multiply same bases, you add your exponents. And then finally last times last. Again, using that formula on the bottom, I will get a squared minus b squared. I'm going to go ahead and clean up my top a little bit. I'll leave my first term alone. There's nothing I can do to simplify that, as well as my second term. However, my third term, I see if I have x to the, well, first of all, I see a 6 under the radical, which does not contain any perfect squares. However, x to the 4th, I can take out 2 groups of 2, and I will not have any left over on the inside. Looking at my last term, if I have 3, I don't have any perfect squares in that. I'll leave that alone. However, x cubed, I can take out 1 group of 2. So I'll have 5x out front, and I'll have 1x left under the radical. As always, if you prefer to use rational exponents, if you prefer to change those to fractions, please make sure you're doing that in your notes, using the method that works best for you. On the bottom, my square and my radical cancel, leaving me with 2x. 5 squared is 25. I look up on top to see if I have any like terms I can combine. I don't, since nothing has the exact same radical part and exact same variable part. Even though my first term and my last term look alike, they both have a radical here. Notice that what's underneath the radical isn't the same, and then also the 5 has an x, whereas the 2 doesn't. On the bottom, same concept. I can't combine like terms since this has an x and this one doesn't. So I'm going to go ahead and stop here with this being my final most simplified answer. And again, I know it's my simplified answer since I cannot reduce any of my radicals any further, and I no longer have a radical in the denominator.